Okay guys, so section 5.1, starting chapter 5, we start out with something called slope fields, but we also talk about some differential equations. So let's start with differential equations. So this first example says determine whether each function is a solution of the differential equation, and they give it to me right here. So this differential equation, this means y prime prime or y double prime or the second derivative of y minus just the function y equals 0. So let me show you what we mean by this. So the first thing I need to do, if this has a double prime right here, that means I need to find the second derivative of this function. If this just has y prime, I can just do it one time, just whatever they're asking for. So first of all, y prime in this case would be cosine. And then y double prime, the derivative of cosine, is negative sine. So I have negative sine of x for this piece. So I'm going to start plugging stuff in. So here's my differential equation. Y double prime in this case is negative sine minus y is my original function. So sine of x equals 0. And they want to know, is this a solution? So in other words, is this true? Well, this is not true because negative sine minus another sign would be negative 2 sine. And that does not equal 0. So this one is not a solution. Okay, so let's look at when it is. So in this one, y prime, don't forget chain rule on this one. So I'm going to leave this coefficient alone, and the derivative of e to the x is e to the x. So this is e to the negative x. But because that wasn't just an x, I have to take it times the derivative of that. That's my chain rule. That's negative 1. So this is the same thing as, I'm just going to bring this forward, so negative 4 e to the negative x. So I just simplified it a little bit. So then y double prime, or the second derivative, would be, leave this alone again, derivative of e to the negative x is e to the negative x times the derivative of negative x, which is negative 1. So this simplifies to positive 4 e to the negative x. So it goes right back to where it was. So again, this is the differential equation I'm trying to see if it's a solution to. So I'm going to plug those in. So y double prime would be 4e to the negative x minus y is 4e to the negative x, again, right there. And that is supposed to equal 0. Well, this minus itself is 0. So this one is a solution. The last one of those types of examples, it actually looks kind of weird. So this one has a c in it. That c just means I have some constant value there. So I could pretend that that was a 2 or a 7 or a negative 3. It's all the same idea. So this is some constant. So when I do my first derivative, again, I'm going to leave this alone. So I'm going to leave that as c. And then I'm going to take the derivative of e to the x, which is e to the x. And because this isn't anything other than x, I don't have to do a chain rule here. So that is totally fine. That is it. So it's interesting how it just kind of stays exactly the same. Double prime, same thing. Derivative of c is still, I'm going to leave that c alone, and this e to the x stays e to the x. So this is just, it never changes. So when I plug it back into that original differential equation, again, it's going to do the same thing. So y double prime was c e to the x minus my y was c e to the x equals 0. This minus itself, yep, is 0. So this one is a solution. Okay, a little more exciting here. So example 2 says, for the differential equation, and they give me this differential equation, verify that y equals cx to the third is a solution. So they're telling me it is a solution. They want me to verify that though. Then I'll do something else after that. So first let's verify it. So in this differential equation, I only have a first derivative. So I only have to worry about a first derivative. So if y equals cx to the third, y prime equals, so that c stays put, and I'm going to take that times the derivative of this, which would be 3x squared. So I'm going to simplify that a little bit and say I'm going to put the c after the 3 because I feel like variables just kind of go after. So it's 3c x squared. Then I'm going to go back to my differential equation. I'll do it over here. So my differential was xy prime minus 3y equals 0. And I'm going to plug stuff in. So this x, I don't have anything to plug in for that, so because I don't have x equals, I have y equals. I do have the derivative, though. That's 3cx squared minus 3 times, I do have y. Y is right here, cx cubed. And they're telling me that that equals 0. So I just have to verify that that's true. So in this case, if I multiply this in here, so the 3 can go up front, the x times x would be x cubed, and there's a c in there. And then this one, same thing, 3cx cubed. These are the same, I'm subtracting them, so yep, I verified it, that is true. The second piece says, then find the particular solution determined by the initial condition. This is true when this is true. So they're giving me 2 values. So I just need to go back to my original equation here, not the differential, but the original equation. So my y equals cx to the third, and I need to solve for c. That's what I need to know. So that means 2 equals c times negative 3 cubed. So 2 equals c times negative 27. I don't know why I made that so little. 27. Okay, so then that means if I divide by negative 27, I get negative 2 over 27 equals c. So then that means my equation is y equals, here's my c value, so negative 2 over 27, and then x cubed. They just want me to write that equation with a particular equation instead of just that kind of general equation. Okay, so that's all for example 2. Example 3, this is where we get into slope fields. So they want me in example 3 to sketch a slope field. So what that means is I am basically going to make little line segments. So here's an example of what a slope field looks like. Basically what happens is they said, what is the slope at this exact point? And then they made just a little line segment of what that slope was. So it's an estimate. So this one looks to me like it's fairly steep. Maybe that's a slope of like 3 or 4 or 5. Whereas this slope right here is maybe a slope of 1, or maybe it's 1/2. These flat ones, that's a slope of 0. And then these are negative slopes, okay? All right, so in this particular one, they want me to just find these 3. Well, they gave me the equation. It's a differential equation. And so here's what this means. Y prime means slope because it's the derivative, right? Derivative is slope. So they're telling me that it's x minus y. So for this first point, this, let me put it right here. So negative 1 comma 1 is the first point they gave me. That means y prime in this case, or my slope, is negative 1 minus 1. So it's negative 2. If I find the slope for the second one, slope equals 0 minus 1. That's negative 1. If I do 1, 1, sorry, that means my slope, or my y prime, is x minus y, or 1 minus 1, which is 0. So I just need to go to those points on the graph over here. So my first point was negative 1, 1, which is right here. It has a slope of negative 2. So I want you to think for a second, if I'm right here and I have a slope of negative 2, that means I would go down 2 over 1. Or I could go up 2 and over 1 this way. So what I'm trying to do is make a little line segment. Let me use a piece of paper here. I'm trying to make a tiny line segment that would make that slope. So I would just put a little line segment like that. Sometimes I really do this, where I put points in here, just like I just did, just so that I get a really accurate slope right there. You could also just say, you know what, it's negative 2, which is a little steeper than negative 1, so I'm going to make it a little steep. Okay, this point right here, 0, 1, the slope was negative 1. So again, like I said, you could think about, I'm going to connect to this point and this point because that's a slope of negative 1. So I could do this, or I could just try to sketch it as close as possible. And then my last point, 1, 1, has a slope of 0. That one's really easy. Just looks like that. And that's all they wanted me to do on that problem. The next one, they wanted me to match the slope field with its equation. So here's some equations, here's my slope fields, going from there. So here's what I would do in this case. I always look for where the slope is 0. Like, where is that happening and how can I make that happen in these equations? So I look at the graph first. In this one, all of these points right here have slopes of 0. So when is that happening? That's happening at every one of these points. So this point is 0, 0. This point is 0, 1. This point is 0, 2. This point is 0, 3. So everywhere where x equals 0, my slope is 0. That's happening every time. So if I look through here and say, well, if x is 0 but y doesn't matter, is this going to be 0 total? No. If x is 0, is it going to be 0? Yes. So this one matches up with this one. On this one, it's the y value that's 0. So let's go ahead and look at that one. It looks like right here, this one, on all of those, my y values are 0, right? So this is 0, this is -1, 0, -2, 0, 0, 0, 1, 0, 2, 0. That happens when y is 0. So this one right here matches up with this one. Okay, so then the last one, this one matches up with this one, but you may want to like figure out, well, why? Why does that one work? So how could I figure that out? So I'm seeing a bunch of 0 slopes all through here. So I could just name a couple of those points. So like, let's look at this point right here. That point is -1, +1. -1, 1. Be careful with that. That's just +1. Okay, so at -1, 1, if I were to add those two together, I get 0, and that's where the slope is 0. So that makes sense, and you could do that for all those points. Okay, so then the last one, they want me to sketch the slope field for this differential equation, and then they want me to use that to sketch the solution that passes through this particular point. So let me show you what that looks like. This one gets kind of messy. So the first thing I would do to sketch a slope field is just start picking points and plugging them in here and find what the slope is. So if I pick the point 0, 0, x is 0, y is 0, that means y prime equals 0. So this slope right here is 0. If I do, let's say I do 1, 0. So my x value is 1, so that gives me a 2 right here, and y value is 0. So I end up with a slope of 2 in that case. At 1, 0, I end up with a slope of 2. So again, I'd go up 2 over 1, down 2 over 1. If I connect those points, it looks about like that. Just kind of a little sketch. If I plug in this one, so -1, 0, I end up with a slope of -2 in that case. Okay, so let's just plug in some more of these. If I do 1, 1, I would get a slope of 3, because that'd be 2 plus 1. So that one's even steeper. And then let's see, I did a bunch of these ahead of time, so I'm going to go ahead and just put them on here. If I did 0, 1, I got a slope of 1. If I did -1, 1, I got a slope of -1. Looks like I've got something weird happening right there then. And then let's see, if I do, what other points did I do on here? 1, 1, -1, 1, 0, 1, 0, -1. I did this one. That one gave me -1. Oh, this one I did wrong, guys. I'm sorry. 0, 1 would give me a +1. I don't know where I came up with -1. I think I was subtracting those instead. Sorry about that. Okay, so let me show you where I got that. So 0, 1 is that point. So if I put a 0 here and a 1 here, this would be nothing. Plus 1 is 1. Okay, that looks a lot better now. I thought something really weird was happening there. Okay, let's see. 1, 0 was a 2. -1, 0 was a -2. I got it. What if I did -1, -1? That slope was 3, so it's a little steeper. Guys, I did all this backwards. Oh my goodness. Let me just start over. What am I doing? Okay, sorry about that, guys. I'm just going to start over here because I messed those up. I'm assuming you noticed that and you were thinking, what on earth, Miss Evans? So let me go back to this one. This was -1, 1. So if I put a -1 right here, I get -2 plus 1 would be -1. And I drew it this way. -1 would go this way. Whew. Okay, this one, if I do -1, 0, this would be -1, that'd be -2 altogether then, so this is a -2. I have completely switched these. I don't know where my brain was. Okay, let's do that again. So this kind of shows you what happens, right? You are not alone if you do these backwards. Okay, this one was 1, 1. So 1 here would give me a 2, plus 1 would be a 3. +3, not negative. I'd go up 3 over 1, connect those. So that's pretty steep. This one at 1, 0 would give me a slope of 2, still fairly steep. Again, it's positive though, going uphill, not downhill. My goodness. Okay. Let's see, was this one right? This one was 0, -1 would give me -1 going downhill. What if I do 1, -1? So 1 times 2 would be 2, minus 1 would be 1, so +1 here. This one, -1, -1, so that'd give me -2 minus another 1 is -3, so that's pretty steep going this way. Negative. Okay, so it looks something like this. I apologize for my mess there. Okay, and then, so let me show you what the books looks like here. So this is what theirs looks like, and you can kind of tell what mine was doing, same thing. So it kind of goes like this. It's going downhill, and then it's going back uphill there. And if you had more around the outsides, you could tell that also. It goes, so all of these are going kind of down, and then these are going back up. So if they're wanting the particular point that goes through the point 1, 1, so 1, 1 is right here on their graph, they just followed those slope fields and kind of sketched a curve through there. When it starts to go back up, they went up through there. So this is the curve they came up with. This is completely a sketch. I do not want you to get too bogged down in the specifics of that, okay? So don't stress so much about it being perfect. This is a sketch, okay? All right.